We would have believed that the side runner dynamo on the bike would become extinct, but then this wonderfully light VELOGICAL RIM dynamo came into play. It weighs 54 grams and does not run on the tire but on the rim. It hardly brakes, it makes little noise, and above all, it does not slip in the rain. These dynamos all have one thing in common. They generate the electricity for the lighting on the bike. What differentiates these three models here is not just the colors, but that's the speed range in which they work best. Which doesn't mean they won't work outside of that range. Here we have in the middle the silver or natural colored tracking dynamo, which is the ideal solution for the normal everyday cyclist. Its optimal range of use is between 4 and 31 miles per hour. For the athletes who are in a hurry, there is the red sport dynamo, and this feels most comfortable between 6 and 37 miles per hour. And for the travel cyclists who are traveling with heavy luggage and rather at a slower speed, we have the special here, the blue special, which works best between 6 and 24 miles per hour. The dynamo has a groove here at the upper end. An O-ring is inserted in this groove, and with this O-ring, the dynamo runs on the rim. Yes, down here are the two connecting wires. That's where alternating current comes out. That means you can't swap the wires, they are the same. They connect to the lighting system, like this. Then there's another plug, and it comes in at the end of the assembly. Down here, I'm just going to put it in a little bit for now. And then there's a grub screw. This grub screw goes in one of the two holes at the bottom and at the bottom of the dynamo, like this. Here you can see the dynamo from below. Now, how is the dynamo attached to the bike? To this end, there is a so-called V-brake holder. The V-brake holder is placed on the brake socket. Here's where the finger is now on the left brake socket from the front. The V-brake holder would thus be put on the brake socket with the help of this screw and the two ball washers. One ball washer, V-brake holder, second ball washer, with the ball washer always towards the holder. Here we also have a drilled distance nut, and here now this whole apparatus would be screwed onto the brake socket. Before that, of course, you have to remove the existing screw from the brake socket, like this. The ball washers have the function that you can align the dynamo, that you can align the axis here. Now, together with the dynamo, the whole thing would look like this. You push the dynamo onto here until this little steel cylinder comes out a bit. I'll take it off for a second so you can see it. That's the steel cylinder, that's the brass tube. You push it onto it, and now we see that the grub screw can be braced with the steel cylinder. I'm going to demonstrate that for a moment. Now we have a connection between the steel cylinder and the dynamo housing. And the steel cylinder is connected to this torsion spring. That is, here you can see now how the dynamo moves with this torsion spring. So, for example, if the dynamo is on the rim like this, if the rim level were here now, and the steel cylinder is too close to it, then the dynamo would be crooked on the rim like this. And there's a trick. You can turn the dynamo by 180 degrees. Like this. Now the dynamo axis has moved further away, because the dynamo axis and this bore receptacle are not symmetrical. It has a lateral offset. Now the dynamo sits straight on the rim. However, we have to remove the grub screw and reattach it so that it presses on the steel cylinder. It is important that there's only one grub screw, and this grub screw must always press on the steel cylinder so that the dynamo can move freely on the brass tube. So now let's take a close look at the dynamo from behind in the direction of travel. That is, the dynamo is mounted on the left brake socket, here again with the two ball washers and the spacer nut. We look at the dynamo from behind in the direction of travel. Now here's where the front wheel would be. And here's the actuating lever. I'll leave that out here for a moment. The actuation lever knows two positions: folded out, folded in. And the dynamo is only folded in and out on this bracket. In the folded state, you can see how the torsion spring works. It presses the dynamo against the rim with an even pressure. When folded down, the distance between the rim and the O-ring should be about 2 millimeters. And now one more remark about the O-ring. Here now we have the small O-ring. This allows the dynamo to run at a slightly higher speed, so that the light is already illuminated at low speeds. People who are in a hurry and who are moving very fast on the road can optionally mount this thick O-ring on here. It improves the smoothness at high speeds.